This is part 3 on Properties of Matter by Jungho Daniel Choi and Simon Yoon from 8C. Properties of matter are different characteristics that they might possess. The first type of properties of matter are physical properties. There are a lot of physical properties such as shape, color, ductility, malleability, length, width, volume, mass, density, area, tensile strength, hardness, texture, magnetism, electrical conductivity, thermal conductivity, surface tension, viscosity, changes in state of matter, solubility, and so on and so forth. Now, physical properties are properties that can be observed without changing the chemical composition of the object itself. One physical property is electrical conductivity. Objects with a high electrical conductivity can conduct an electric current very well. Objects with a low electrical conductivity cannot. This shows a circuit that connects a battery and a light bulb. If the object placed in between the two clips completes the circuit and is able to have a high electrical conductivity, it will turn on the light bulb. Paper does not have a high electrical conductivity, so it does not light up the light bulb, but this aluminum wire, on the other hand, will light up the electrical light bulb if you observe closely. Again, water does not conduct electricity very well. It has a low electrical conductivity, therefore the light bulb has not lit up. Now, why is all of this important? Why is knowing which materials can conduct electricity better important in our lives? The answer is because in our modern world, we use a lot of electronic technology, such as cell phones, computers, and other things like that. Now, all this electronic technology could not be possible without knowing which substances will conduct electricity. Metals tend to conduct electricity better, and that is why we use them in electronic devices. Magnetism is another physical property, and it shows whether objects are affected by magnets or not. If it is affected by magnets, it will arrange itself in a magnetic field around the magnet. This is the magnet we will be using to demonstrate magnetism. This is iron filings, and when placed around a magnet on a piece of paper, it arranges itself in a metallic field, and you can see the three-dimensional field that's kind of like surrounded around the magnet, almost like a football. This is the same magnet as before, but when sodium bicarbonate or baking soda, a non-magnetic material, is placed on it, it does not form a magnetic field. Now, why is the physical property of magnetism important? Again, it's used in electronic technology, just like the electrical conductivity, but in this case there's even more to it, in that the Earth has a magnetic field. The Earth's magnetic field is what makes compasses work, and it helps with navigation in the olden days and now a lot. So electronic technology and compasses both rely on magnetism, which are two very important things. Another physical property is surface tension. Surface tension is a force that acts on the particles at the surface of a liquid and sometimes causes liquids to form spherical drops. This shows water to the right and water mixed with detergent to the left. As you can see, water has spread far less than the detergent, meaning that the water with the detergent has a far lower surface tension than the water itself. Why is surface tension important to life on Earth? Well, if you've ever seen footage of animals walking on water, the high surface tension of water is what allows it to do that. Also, plants will rely on surface tension to transport water, which has high surface tension, up and down and in between their cells, which is vital for the plant's survival. Solubility is another physical property, and it describes the ability of substances to dissolve, especially in the substance water. This is a video of salt being dissolved in water. Salt is very soluble in water, and therefore it can be dissolved. However, there is something unique about salt in that this is not a physical property, it's a chemical change, but we'll get into that later. Besides salt, all other soluble materials are solubility is a physical property, not chemical. This shows flour being, well, trying to be dissolved. Flour is just dumped in water, but as you can see, it's not dissolving. because it's not soluble in water. This is a physical property, that flour is not soluble. And if you'll wait and see, the flour kind of materializes on the bottom in chunks rather than actually dissolving into the water like the salt did. This shows that flour has a low solubility, lower than salt. This next video will show sugar being dissolved. Sugar also has a high solubility, so this physical property of sugar makes it easy to dissolve in water. Now, the sugar, like the salt, is dissolving, but it's different in that this is a physical change, not a chemical one. And if we stir it a little, it's going to dissolve better. Why is solubility important in our lives? Well, first of all, there's the more trivial aspect of us dissolving, say, sugar into our beverages, such as tea and coffee. Now, there's the more critical aspects, such as the minerals that are dissolved in water and other foods that are critical to our nutrition, and the dissolved substances in our body fluids, which determines well-being and sickness. So solubility is, in the end, very important to our lives. Now, there are less chemical properties that we can observe in a 8th grade science lab. Some of these are flammability, reactivity, oxidation, toxicity, and stability. Now, this is a reactivity to hydrochloric acid, HCl. The one in the bottom left that's bubbling right now is zinc after it's been put into hydrochloric acid. After hydrochloric acid was put on it, as you can see, it's bubbling and releasing gases and fumes. Now, this is aluminum. And aluminum takes a bit slower to react. The aluminum foil, it has to get all the way through before reacting with the hydrochloric acid. This is iron wire that's all tangled up. And we'll see what happens in a moment. That is a wooden toothpick. Although it was already protected in a layer of waxy thingies, now, because a small chunk has been broken, it's sitting directly in the hydrochloric acid without the protective layer that was there before. And now if we wait a bit longer, we can see what happens to the aluminum. So the zinc is turned all black.
You can start to see
but this is a bit later on, and it's starting to bubble up, if you can see,
right through
with the aluminum foil.
You can see some discoloration in the center. And this is going to produce.
And soon enough, it's going to be dissolving completely.
Most of them are just
and
hydrogen.
That's reactivity to hydrochloric acid.
Aluminum sulfide, but in a very small.
There is a reaction between the elements of aluminum and the acid. Now, nothing seems to be happening to either the iron or the wood, but the aluminum is what we should be looking at now. Yep, it's starting to dissolve. You can start to see a bit of discoloration in the center.
It's something, again, there's a property that we need to know. I mean, a lot of people might mix something and walk away.
The wood's still not reacting, even though it's probably been completely soaked through with hydrochloric acid now. We have to wait for the aluminum, however, to have the hydrochloric acid soak through all the way through.
Looks like the wood is
and now the iron or the wood doesn't seem to be reacting either. So we can say that the iron or the wood will not react directly to hydrochloric acid. And this also demonstrates a good property. Some reactions, especially chemical ones, take place after a long period of time. And this is actually pretty important to know, because what if we say, let's look at the aluminum, which is now completely dissolved. What if something dangerous happens after we've just left it alone, thinking nothing will happen to it? See, the aluminum has completely dissolved now. I think it's pretty clear why it's important to know about the reactivity of acids. It's because acids are dangerous and you don't want to mess around with them and get hurt unnecessarily. This is the chemical property of flammability, which describes an object's ability to catch on fire. Now this is a demonstration of the flammability of hydrogen. Hydrogen is a flammable gas. This is what happens when something that burned was recently put out is put into oxygen. Oxygen is not flammable, however, it is an oxidizer, and it's also as important in keeping a flame alive as the fuel, even though it isn't flammable. As you can see in this photo, paper is a very flammable material. As you can see here, wood is also a very flammable material. Again, it's pretty clear why flammability and knowing what is flammable and what isn't is pretty clear, because you don't want to burn yourself and you want to know what things are flammable. Now this next clip will demonstrate not only oxidation, but more importantly, sodium's reaction to water. It has a strong reactivity. If you can see, this is a very tiny bit of sodium in a small amount of water, and yet still it's reacting this violently to it. This just shows how important reactivity is, even though the quantities may be small. Now the previous clip showed oxidation and sodium's reactivity to water. Now this is very important, because if you just for some reason happen to have some pure sodium lying around, you don't want to keep it in a damp environment, because it's going to react violently. So these are various different ways in which substances differ. The properties determine how a substance behaves and how they are different from one another, and from that we can use materials as they are fit to be used.